Hello everyone, this is Anand Goud, Assistant Professor from Civil Engineering Department in Institute of Aeronautical Engineering. So today we will discuss about the topic Soundness Test of Cement by Chatelier Method. Coming to the course outcomes here. So after learning about these topics, we are going to summarize the basic physical and chemical properties of construction materials for determining the quality of concrete. Okay. And contents of this lecture is we are going to learn about the definition of soundness and the test method of soundness test by Chatelier Method. So coming to the definition of soundness here. So soundness of the cement is defined as the ability to retain its volume after it gets hardened. So when you prepare a cement paste, okay, by adding the water to the cement powder, so after hardening, the cement will not retain its initial shape. Okay, whatever the member we have casted, okay, so that shape will not be retained due to the quality of cement. Okay, it may be due to the excess content of lime, excess content of magnesia. Okay, these particular materials were causing the property of cement to change its volume. Okay, so that is what the soundness. Okay, if the cement paste, okay, if the cement, whatever the cement you are using, that is not changing its volume, okay, we are not getting any type of changes in the volume or else cracks, then that is called as a good quality cement. That means sound cement. Okay, so this means that a properties the properly sound cement will undergo minimum volume change after it converts into the hardened state. So after hardening, okay, when you prepare the cement paste by mixing with the water, so after hardening, okay, the volume change will be very less. Okay, so that is called as a sound cement. Okay, and in the soundness test of cement, we determine the amount of excess lime. Okay, so here the whatever the volume changes we are getting in the cement, that is due to the excess content of lime or magnesium, right? So in this particular test, we are going to determine the expansion or else soundness of cement due to the excess lime. Okay? And this test can be conducted by Chatelier method and autoclave method. Okay, by using these two methods, we are going to find out the soundness property of the cement. Okay, that is, the first one is Chatelier method. Okay, and the second one is autoclave method. So coming to the significance of soundness test on cement. Okay, what is the need of doing the soundness test on cement? See, cement is a composition of lime, silica and aluminium, magnesium, alkaline and sulfur trioxide, iron oxide and calcium sulfate, right? So among all these particular composition, materials, lime itself constitutes around 60 to 70%. Okay, lime content will be around 60 to 70%, right? So hence a cement deficient in lime will quickly set, okay, and affect the property of the cement. So due to the less content of lime content, okay, so the cement property will change, like the setting time of the cement will reduce, and ultimately it is going to affect the quality of the cement, right? So lime content in higher amount will make the cement unsound. Okay, so this particular unsoundness of the cement will be obtained due to the excess lime content. Okay, so unsoundness in the cement is due to the excess of lime and excess of magnesia or excessive proportions of sulfates. Okay, so normally the lime content should be around 60 to 70%, right? So if the lime content is more than 70%, then that will cause the unsoundness of cement. That means unsoundness is nothing but here. See, if you take the lime content more than 70%, then what will happen? That free lime content, okay, whatever the excess lime content is there, that lime content will not react with any other materials in the cement, and that excess amount of lime content will be in a free state. Okay, it is not going to react with any other materials in the cement. So whatever the excess amount of lime is there, that is going to be in a free state, and whenever the moisture content is added into the cement paste, that lime content will react with the water, and they are going to change its volume. Okay, they are going to bulk. Okay, that is the reason we are going to get the cracks in the cement. Okay, that is why we have to use correct proportions of lime content or magnesium content or sulfates in the cement. Okay, so an unsound cement will affect the quality of the cement. So unsound cement, that means with the cement which is having more content of lime, that will affect the quality of the cement. Okay, and this demands of soundness test of cement before using it. So due to, I mean, presence of excess lime content, the quality is changing, right? So if the quality is not good, then we cannot use that in the construction. So before using in the construction, we have to check the quality. And one of the property of that quality is soundness. Okay, so that is the need of this particular soundness test on cement. So through this particular test, it is ensured that the cement won't undergo any sort of expansion due to the presence of excess amount of lime. So by using this particular test, we can find out the unsoundness of the cement or soundness of the cement due to the presence of excess amount of lime content. Okay, so now we will discuss about the test procedure of soundness test. Okay, so here the aim of this particular experiment is to determine the soundness of the given sample by using the Chatelier method. Okay, we are going to find out the soundness. Okay, and this particular test is specifically for excess amount of lime content. Okay, whatever the expansion we are going to get in the cement, that is due to the excess amount of lime content. Okay, and that particular quality will be determined now. Okay, and coming to the apparatus part, so here we are going to use Chatelier mould. Okay, this is the Chatelier mould. Okay, and water bath. Okay, and cement, glass sheets. Okay, this is the glass sheet, and the mixing pan. Okay, we are going to mix in the pan, and trowel and weight. Okay, these are the weights. Okay, so this is the Chatelier mold, and these are the glass plates, and these are the weights. Okay, which, I mean, where these weights will be used on the particular mold. Okay, and this particular test will be conducted based upon the IS code, that is IS 4031 Part 3 1988, and the code book name is Methods of Physical Test for Hydraulic Cement. Okay, by following the test procedure mentioned in this particular code book, we are going to conduct the experiment. Now, so coming to the detailing of this particular equipment, that is Chatelier mould. See, it consists of a small split cylinder, okay, of spring brass or other suitable metal. Okay, so this particular cylinder will be having one small slit here, okay, small gap, okay, which is made up of with the brass metal or else any other suitable metal. So it is 30 mm diameter and 30 mm height. Okay, the diameter of this particular cylinder is 30 mm. Okay, 30 mm diameter, and height of this particular cylinder is also 30 mm. Okay, so next, on either side of the split, there are two indicators which are attached to the either side of the split. So you can see here. Okay, see, this is the split we have, and this is the needle. Okay, this is the needle or indicator. Okay, of 165 mm long. Okay, the length of these two indicators are 165 mm long with pointed ends. Okay, the ends are pointed like this, needle. Okay, so this is about the Chatelier mould. Okay, the diameter is 30 mm and height is 30 mm, and the length of the indicators are 165 mm, which are attached to the cylinder on both sides of the split. Okay, next one, coming to the procedure. First part of this procedure is preparation of cement paste. Okay, so first we have to prepare the cement paste to fill in the mould. So prepare a cement paste with 0.78 times the water required for standard consistency. So before this particular test method, we have already discussed about the standard consistency test, right? So in that, we are going to find out the amount of water required to get the consistent cement paste. Okay, that is notated with the P. Okay, we will get some X percentage, right? That is the standard consistency. So now, while checking the quality of the cement by soundness test, So here, to prepare the cement paste, we are going to use 0.78 times of standard consistency of water we are going to use. Okay, and that cement paste, which is prepared by using the same water content, is filled in the Chatelier mold. Okay, filled in the Chatelier mold without any gaps. Okay, properly, and kept on a glass plate. Okay, so after filling the mold with cement paste, keep this particular mold on the glass plate like this. Okay, and then on the top of this particular mold also we have to place one more glass plate. Okay, so the mold is covered on the top with another glass plate. Okay, like this is the split cylinder. Okay, and below this we have to place non-porous plate, glass plate, that is to avoid the transportation of moisture content from the cement paste. And then after placing the cement like Chatelier mold on the glass plate, and the top of this mold is also covered with the another glass plate. And after placing the glass plate, again you just weight the weight. Okay, as we have seen in the before picture. Okay, these two weights are placed on the glass plate. Okay, yeah. So now after preparing the setup of Chatelier mold, now take this particular mold. Okay, immersing and measuring. So now submerge the mold assembly in water at 27 degree plus or minus 2 degrees for 24 hours. Okay, take out the total setup and place it in the water bath. Okay, for 24 hours at a temperature of 27 degree plus or minus 2 degrees Celsius. Okay, so after placing it for 24 hours, okay, so record the distance between the indicator points. Okay, take out the total setup and record the distance between the, and if you see the top view, it will be like this. Yeah, okay, this is the top view of the split cylinder Chatelier mold. So after keeping the Chatelier mold for 24 hours in the normal water bath, now take out the total setup, okay, from the water and measure the distance between these two indicators, and that will be noted as L1. Okay, so record the distance between the indicator points after 24 hours as L1. Okay, so now again submerge the same total setup after measuring the initial distance. Submerge the total setup again in the water bath. Okay, so submerge the mold again in the water and heat the water and bring to the boiling point about 25 to 30 minutes and keep it boiling for 3 hours. Okay, so now after keeping the Chatelier mold setup in the water bath second time, now heat the water such that the water should reach the boiling point within 25 to 30 minutes. Okay, and heat the same point, I mean same mold, I mean same setup for 3 hours. Okay, for 3 hours we have to heat the total setup. Okay, now remove the mold from the water. Okay, after heating that particular setup for 3 hours, remove the same from the water bath and allow it to cool. Okay, allow it to cool and measure the distance between the indicator points. So again, after cooling this particular setup, again measure the distance and that will give you the value of L2. That means the cement will expand. Okay, and that will be noted as L2. Okay, so now the difference between the two measurements, like initially without heating the setup. Okay, without heating the setup, when you keep the setup in water for 24 hours at normal temperature, that value will be noted as L1, right? So, and after heating the total setup for 3 hours, that will be noted as L2. Okay, now we have to note down these two values. Okay, and the difference between these two measurements represents the expansion of the cement. Suppose initially you may get the value of expansion like 5 mm, for example. Okay, and second time after heating the cement, the different, I mean, you will get the value between the indicators as 12 mm, for example. Okay, so now L2 minus L1 or L1 minus L2. So if you do this calculation, the expansion will be how much? It is 7 mm. Okay, so now this is what the expansion of the cement. Okay, initial value minus final value. So that will give you the value of expansion. Okay, and that will be considered as a soundness of cement. Okay, depending upon the value we got, we are going to classify it as whether it is sound cement or unsound cement. Okay, so observations and reading. So here calculate the soundness okay, expansion of cement using the formula L1 minus L2, okay, by differentiating, by subtracting the value of L1 from L2, you are going to calculate the expansion. And L1 is nothing but measurement after 24 hours at 27 plus or minus 2 degrees, okay, and L2 is nothing but measurement of expansion after 3 hours at boiling temperature, okay. So now this is the observations we are going to note down while doing the experiment. And limit of expansion. So after checking the expansion value, so we will be having some limitations based upon the type of cement, okay. If the limit is crossing, then we are not going to conduct, we are not going to use in the construction, okay? And that may not be suitable for ideal preparation of cement, okay. So now see, the first one is 10 mm, okay. The expansion can be 10 mm for OPC and rapid hardening cement, low heat cement, and Portland Pozzolana cement, okay. For these types of cements, we can allow the expansion up to 10 mm, okay. Beyond 10 mm we cannot allow, okay. For good quality OPC cement or RHC cement or low heat cement or PPC cement, the expansion should be within 10 mm, then only we can call it as a quality cement, okay. Suppose if the expansion is crossing the 10 mm, then we have to reconduct the experiment, or else we have to recheck the quality of the cement, okay, or else we have to avoid the usage of such type of cement for important structures, okay. And next one, 5 mm for high alumina cement, okay. So the expansion is limited to 5 mm for high alumina cement, okay. So this is the limit for expansion of cement, okay. And this is about the testing of soundness for quality checking of cement, okay. This is how we are going to conduct the experiment on soundness test, okay. And this is the reference we have used. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.